Hi everyone, so this video is going to be going over different types of polar graphs. We're going to be starting with lines and circles, our two most basic. So in our last lesson when we talked about converting between rectangular and polar, we saw some equations that turned out to be lines and some that turned out to be circles. So we know that for lines in Cartesian coordinates, we have y equals mx plus b. We could have y equals a constant k, and remember this is a horizontal line. Sorry, it's getting a little bit smushed. And then we could have x equals k, and this is a vertical line. So these are Cartesian, and now when we go down here, these are our general equations for a polar line. So we could either have theta is equal to a number a, any number, and that's going to be a diagonal line. We could have r equaling a letter a divided by cosine of theta. This is going to be a vertical line. Or we could have r equals a divided by sine of theta. So this is going to be a horizontal line. So let's go through a couple examples of lines. So our first example here, number 13, is that theta is equal to negative 5 pi over 6. And remember, negative 5 pi over 6 is the same thing as 7 pi over 6. So remember that we are looking from our positive x-axis, and we're looking to measure where 7 pi over 6 is. So we know this right here is 6 pi over 6, and then these lines here, so this is 7 pi over 6 right here. I know that this doesn't look like the normal circular graph that we have, but if you break it up, that's how it's measured out. So we know that our theta is equal to 7 pi over 6. It doesn't give us a radius. So all that we know is that we could have any possible radius as long as the angle from the positive x-axis is 7 pi over 6. So any point on this line, that angle from the positive x-axis is going to be 7 pi over 6. But then remember, if we have a negative radius, it goes to the other side of that line. So this also continues into quadrant 1. So this right here would be if you have a positive radius, and this would be if you have a negative radius. So when you have theta equaling some angle, you're going to get a diagonal line. I don't know if I spelled that right. I'm not going to lie, guys. So, diagonal line. Okay. I did. I just want to check. Now, number 14, we have r is equal to 3 divided by cosine of theta. So, what happens if we multiply the cosine of theta over? So, we now have r is equal to, r times cosine of theta is equal to 3. And remember, r cosine of theta is the same thing as x equals 3. So we know that when we have x equals 3, if we're on a normal Cartesian coordinate, that means that we have a vertical line. And it's the same thing in polar coordinates. So we're just counting out, instead of counting out tick marks on the x-axis, we're counting out circles and layers of circles. So this right here is 1, 2, and 3. So my x just goes like this. So when we have r equals 3 cosine of theta, this is a vertical line. And last but not least, r is equal to 2 sine of theta. So same thing, if we multiply both sides by sine of theta, we have r sine theta is equal to 2. And replacing this with y, we have y equals 2. And then just like we did over here on our graph of the x equals 3, we're going to count up 2 circles. And my line just goes straight across like that. So when you have r is equal to a number divided by sine of theta, this is a horizontal line. So those are the 3 types of lines that you're going to see. Now we move on to circles. So circles, we know that typically we have something in our Cartesian plane. We usually have r squared, so this is the radius of your circle, is equal to x minus h squared plus y minus k squared, where r is your radius, and then the point h comma k is your center. So quick review of what that looks like in Cartesian points, because now we're going to transition into polar points. So you can either have r equals a, and when r equals a, this is just saying that your radius is a, you're centered at the origin, and again, radius is a. You can have r is equal to a cosine of theta. For this one, you have your center at a divided by 2 and a radius of a divided by 2. So this means that your diameter is a, since the radius is a over 2. And then same thing here when you have a sine of theta. The only difference is your center switches so that it is at 0, comma a over 2 instead of a over 2, comma 0. So for these ones, your diameter is equal to a, not your radius. So these make more sense with examples. So let's go down here, work through these. So for this first one here, r is equal to 6. This is just saying, all right, my radius is equal to 6. I have a circle, radius of 6. This one is centered at 0, 0. So we count out 1, 2, 3, 4, 5, 6. And then it's just around this circle here. Wow, my circle drawing skills have not improved. That is one ugly circle. I am so sorry. All right. Anyways, r equals 6. Circle with radius 6, centered at 0, 0. All right, now we move on to the more fun ones. R is equal to 6 cosine of theta. So first thing that we notice here is that 6 is a positive number. All right? 6 is our diameter. So since this is positive, we are going to be looking in the quadrants where your cosine is positive. So cosine is positive, cosine theta is positive in quadrant 1 and quadrant 4. So here and here. So our circle is going to be balanced between quadrant 1 and quadrant 4. And remember, our center, since we have a cosine, is at a over 2, so 6 over 2, comma, 0. So we know that that is 3, comma, 0. So we go out 1, 2, 3. This is the center of my circle. And then since its radius is 3, 1, 2, 3. And then we know here is the other side of that circle. So I'm going to try to make this as not ugly as possible. Had too much coffee, my hands are shaking. So this is our circle. That is, r is equal to 6 times cosine of theta. Moving on to our last one here. R is equal to negative 4 sine of theta. So we know that 4 is our diameter. And then since this is negative right here, we are going to be looking in the quadrants where sine is negative. So since we are super experts at where our trig functions are positive and negative, we know that sine is negative in quadrant 3 and quadrant 4. So our circle is going to be between quadrant 3 and quadrant 4. Now we look here for where our center is, and our center this time is going to be on the y-axis. So my x-coordinate is 0, and then my y-coordinate is negative 4 over 2. So 0, negative 2. So we start here, go down 2, that's the center, and then my radius is 2, so we move 2 circles down and 2 circles up, and we make that circle there. So these are our 3 types of circles, and then our 3 types of lines. The next video will go over roses, which are a little bit more complicated. So stay tuned and head on to that next video.